It's an exclamation point. It's great. So the rule is they must be the same index, and then when multiplying, you multiply coefficients, and then you multiply radicands. Okay, does that make sense to everybody? So just to remind you all the parts of the radical, like that's the index. And if this is 3x, this whole thing under here is your radicand. Okay, so you must multiply coefficients. And you guys know what I mean by coefficients. It's the number outside. So like if this had a 2 in front of it, that would be a coefficient. So not a ton of rules, but they have to be the same index, multiply coefficients, multiply radicands, call it done. So it's like multiplying is really nice. It's not super complicated, but with that being said, you do have to remember your exponent rules, things like that. And anyway, we'll get into it. Okay, so example number 1 there. So I check to see they're both square roots, so I can go ahead and multiply those, nice and easy. I'm going to be honest with you, I don't think I'll ever give you a trick question where they're not the same root. Like, I want to see that you can multiply properly. So first thing, I'm going to multiply the coefficients. So what's negative 3 times negative 4, or positive 4? Now, I'm writing this down. You guys don't have to do this step. You can do it in your head. But I'm just going to write it down so your notes are complete. So now, so this is step 1. This is multiplying the coefficients. Now we're going to multiply the radicands. So I'm going to have 2x times 6. Now notice that both of those are under the root sign because they are radicands and they stay radicands. So negative 3 times 4 is 12. Square root. And then what's this multiplied together? 12x. All right, now let's go a little bit further with this, is let's simplify it. So this is 5.1 again, okay? So you did the multiplying, now we're gonna go back to 5.1 and we're going to simplify. So, what are the factors of 12 that will have the largest perfect square in it? 1 and 12, because 1's a perfect square, right? What's another one? 3 and 4. So 4 is a perfect square, and 3 is the other factor. Oops, sorry, you guys can't see that. All right, so I'm going to keep my coefficient. So negative 12 gets rewritten. My 12 I'm going to write as square root 4, square root 3, square root x, because there's factors that x are going to be 1 and x, and there's nothing else there. Can I square root 4? Yeah, it's perfect square. So I'm going to have negative 12 times 2 times root 3, times root x. I said 3 and then I meant to write x. What's negative 12 times 2? Negative 24. And I just multiply these two back together and they stay under the radicand. So if you left it here, you completed the multiplying. But you didn't give me the answer in the simplest form. So this is the most correct answer. All right, so if you leave it here, you're not going to get full marks. I expect it to be in simplified form. So that's 5.1. So that's what you're going to have to remember for 5.1. I may need some more room. I don't know about you guys, but I might need some more room to do these examples. Okay, we're ready to do the next one? Okay, are they all square roots? Yeah, so I'm good to multiply them, right? That's the first thing I'm going to check, make sure the indexes are the same. And now this one I'm going to actually have to leapfrog. So I'm going to take this monomial and multiply it by both terms in the binomial. So really what I'm doing is 7 root 3 times 5 root 5, subtract 7 root 3 times 6 root 3. Right, so I'm doing the leapfrog. You don't have to write this step if you don't want to. I'm just trying to make sure your notes are full and complete so that you can see every step as we go. Okay, so let's do this first one. So we're going to multiply the coefficients. 7 times 5. 35, folks, 35. And then 3 times 5, so that's going to be root 15. And then we're going to say subtract, what's 7 times 6? 42. And 3 times 3? Root 9. Now here, you've done all the multiplying, but what's our next step? We got to simplify it, right? So you're not, just because you did the multiplying, you're not quite done yet. Let's talk about the factors of 15. Are there any factors of 15 that would have a perfect square in them? It's 3 or 5 a perfect square, right? So 3 and 5 are our only factors, and none of them are perfect squares. So I actually can't simplify this. This one stays. What about root 9? It is a perfect square, right? So you can just you can just do the square root. So we're going to keep 35 root 15 minus 42 times 3. 42 times 3? 126. Look at you guys and your massive multiplying skills. So this is the most simplified correct answer. So you see how the multiplying...
Good afternoon, everyone. This is person students to come to the forum, please. We're looking for Donovan Morris Bitter, Akira Linklater, Gavin McCallum, Kitiana Pearson, Ruben Cook, Charlie Dysart Linklater, Lane Cordell, Havish Gorga, Kira Hart, Lyndon McKay, Julia Redhead, Blaine Spence, Wilfred Spence, Chad Cordell, Franshu Diora, Clayton Foray, Brock Slett, Dalray Beatty, Emily Saroe, Jemima Hart, Gordon Slett, Tisongwea Martin, Zane Mercury, Jerry Spence, Savannah Thompson, Harlan Trout, Desmond Clemens, Dakota Hart, Dryden Keeper, Alexander Yasik, Nate Anderson, Thurston Beardy, Hyacinth Cook, Gage Cordell, Mitchell Corshane, Brenda Fiddler, Hannah Flett, Landon Hallbrook, Gerald Hart, Samantha Hobson, Avery Lajoie, Rayanna Lavallee, Summer Lloyd, Tiana McKay Tom, Desiree Miles, Tyler Sanderson, Braden Spence, Carmel Wood, Kendra Dick, Deandra Dumas, Jalen Carey, Cody Trout, Isaiah Hassan, Wyatt Milligan, Cassie Thomas, Marcus Cook, Vinnie Cordell, Amaziah Flett, Jonas Kirkman, Elliot Linklater, Jada Hassan, Kobe McKay, and Nolan Pronto. Thank you for your patience.
Okay, so that's all going to be on the video. And that'll be a nice, maybe just fast forward through that part. Okay, last one. So this is, you have two binomials, so you're doing distributive property here. So we're multiplying it through here and here, and then we're taking the second term and we're multiplying it through here and here. So even though they're radicals, this is the exact same way you learned how to multiply polynomials in, I don't know, grade 9 maybe? I don't know when you learned. I'm going to go with grade 9. Grade 8? Okay, so my first two are going to be, so let's cut out some steps. So my first two are those two. And everything's roots. We checked everything's roots. 8 times 9? 72, and we're going to have root 10. Okay? Now I'm going to do my next two. I'm going to do this one and this one. Now notice it's an add, so those are positive. So 8 times 6, 48. And then 2 times 10, hopefully is 20. And now I'm moving to the second term. So that subtract 5 turns into a negative 5. And we are going to times that by 9 root 5. Now, is there a root on this one? No. So the only thing you're going to do is multiply those coefficients, the 9 and the 5. Well, it's a negative 5. So negative 5 times 9 is negative 45. And then you just put the other root there. Okay? And then the last one, I don't know, I'll grab an orange. So we've got our negative 5 again, and we're going to multiply it by the 6 root 10. So negative 5 times a positive 6 is going to be, I'm going to squish this in, negative 30. And then again, there's no root on the negative 5, so we just rewrite root 10. Okay, now we got to put it all together. Okay, we can do this. Let's talk about 10 for a minute. Well, can we combine some 10s together? Let's simplify first. Let's talk 10. Does 10 have any factors that are perfect squares? No, 1 and 10 and 2 and 5, right? So there's no perfect squares there, so 10 is as simplified as it gets. So notice that there's a like radical here. So this again, as we're going back to 5.1, is the simplifying and the combining. So I have 72 root 10s minus 30 root 10s. How many root 10s do I have? 42 root 10s. Right, so we combine those together. Again, we're mathematicians, so we're gonna do what works efficiently. Okay, now looking at this 20 and 5, obviously I can't combine them because they're not like radicals yet. Can I simplify 5? No, it's a prime number, right? So right away I know I can't do anything to that. What about 20? What's 20? 4 and 5. So we're going to have plus 48 times root 4 times root 5 minus 45 root 5. And those two got combined, so that's that right there. Okay, so we're going to have 42 root 10 plus 48 times 2 times root 5 minus 45 root 5. So 42 root 10 plus 96 root 5 minus 45 root 5. Can I combine like radicals now? Yeah, so now I can combine these two. So 96 minus 45. I love it. Are you sure 41? 51. We sure about that? We sure? You guys are correct. 51 root 5. So that is my answer. So you can see how a nice little easy multiplying thing has turned into like much more complicated with the simplifying radicals. The reason we're going to get really good at simplifying radicals is when we deal mostly in grade 12 with no calculator. You're going to be adding, subtracting, multiplying radicals because that's what we're going to do. It's a lot of radical work. Okay, dividing radicals, just as easy, but dividing is always harder. Again, have to have the same index. Divide the coefficients, divide the radicands. Easy peasy. So if we look at this one, what's the answer going to be? What's 4 divided by 2? 2. Good job, everybody. And then what's 6 divided by 3? 2. Ta-da! It's not very exciting, but that's again, the same rules apply for both dividing and multiplying. Can I flip? What? Sure. You don't need a whole pass stop, it's right there. Okay. So we're gonna do something completely different. We're gonna rationalize the denominator. And when I talk about rationalizing the denominator, all it means is we're gonna take the radical out of the denominator. But we gotta do some math, so we're gonna change the way it looks. Okay, super easy with a monomial denominator. So everybody knows what monomial is. It's a single term. There's no add or subtract signs. So a monomial is a single term. We're going to multiply the entire fraction, so top and bottom, by the term from the denominator. Okay, what's the denominator in this one? 2 root 3, right? So you're going to take that. So just a quick question. What's 2 root 3 divided by 2 root 3? 1. Anything divided by itself is 1, right? So if you multiply something by 1, does it change its value? No. So again, we're not trying to change the value, we're just trying to change the way it looks. So let's multiply. What do we got going on there? So how do you multiply fractions? Straight across the top, straight across the bottom. So what's our numerator now? 10 root 3. Good job. What's our denominator? 4 root 9. What can we do there? We're going to like our goal is to get no radicals on the bottom, no root signs on the bottom at all. So can I take the square root of 9? Yes. So I have 10 root 3 over 4 times 3. So I have 10 root 3 over 12. Am I done? Hint, hint, if I'm asking that question, the answer is no. Am I done? No. What do I need to do? That's the hard part. I need to reduce the coefficients there. Can I reduce that fraction? Can I reduce 10 over 12? What do I reduce it to? 5 over 6. So we're going to have 5 root 3 over 6. This is the most simplified correct form. Okay, so I'm going to hit pause, and you guys are going to do the second one. On that. I'm going to freeze the screen so you can't see what I'm doing. What are we multiplying by? 5 root 2. Both top and bottom. Let me know when you're ready. Okay, you guys want to see what I got? So I think the common mistake would have been to stop here. But you can divide 10 by 10. Those go into each other evenly, or you can reduce it. 10 divided by 10 is going to be 1, but we're not going to write the 1 in front of the root 6. Did I screw anything up? Oh, anybody want to call me out on what I screwed up? I did the square root of 25. See, I was all cocky and thought I knew what I was doing. Okay, let's try this again. 25, so that's going to make that 50. And so now this is not going to be root 6. What's it going to be? Pardon? No, you guys are good. I screwed up. So easy to make mistakes. But the whole point of this is that we're trying to not have a radical on the denominator. So if you have a radical still in the denominator, we have a problem. Okay. Last one. Well, not the last one because that's not how we roll in here. What are we multiplying by? Root 2. So again, remember that it always has to be top and bottom because we don't want to change the value. And as long as you do the math right, which I wasn't good at. So this one is a binomial on top. So I'm kind of working backwards. I'm going to multiply it in here and I'm going to multiply it in here. So what's 2 times root 2? 2 root 2. And then root 3 times root 2. Root 6. Is it plus or minus root 6? So it's going to be add root 6. And then root 2 times root 2 is going to give me root 4. And then we're going to have 2 root 2 plus root 6 all over 2. Now I know some of you will be tempted to go 2 divided by 2 and those cancel each other out. But that would be incorrect. And I would fare to say that's almost like killing a kitten. In math, those are kind of the same level. Because really what this means is you have 2 root 2 divided by 2 plus root 6 divided by 2. So you can't just cancel these out because that root 2 goes into this first term and it goes into the second term. So you can't just cancel it out here and say it's root 2 plus root 6. You can cancel these out and write root 2 plus root 6 over 2. Like you can do that as an answer. But I'm going to be honest with you. Most times, we're going to leave it like that. Like this is the one where we leave it. If I can't put that 2, like get rid of the denominator into both terms, I just leave it over one denominator. But you would be perfectly correct if you did this. Okay? We all good? Okay, so now we're going to do the harder part of this. Big deep breath in. It's going to be good. I'm going to switch to a pink marker because it's going to be better. Okay, so when you have a binomial denominator, so again, binomial means that you have 2 terms. And the terms in a polynomial are separated by add and subtract sign. Maybe pink won't be my friend. I'll use this one. Okay, so do you guys remember difference of squares? Do you remember that? Can you guys factor that for me? Brilliant. And so what do we notice about these difference of squares? Oh, I don't listen very well is step 1, don't listen very well. What do we notice about them? The terms are the same, what's different? The sign, right? Like they have an X, they have a 2, one's an add, one's a subtract, they're the exact same. So when I talk about, you're going to multiply the entire fraction, so again, the entire fraction, by the conjugate. So the conjugate is the missing difference of squares factor. That's the best way I can explain it. And the reason why is you were trying to get rid of it. So if this one's the subtract, what's the missing one? It's going to be the add one, right? So it's the missing one. So we're going to multiply this one by 4 plus root 6. And whatever we do to the bottom, we have to do to the tops, because again, that gives us a value of 0. Okay, you ready to do the multiplying? Okay, let's multiply. 5 times 4, 20. 5 times root 6, 5 root 6. Okay, now the denominator, it's 2 binomials. So 4 times 4, 16. 4 times positive root 6. So it's going to be add 4 root 6 because it's positive, right? Now we're going to do the other side. Remember, you got to take the negative in front of it. So negative root 6 times by 4. So negative 4 root 6. And then negative root 6 times positive root 6. Negative root 36. Right? Okay. Whew. Now we're going to eliminate some stuff. So 20 plus 5 root 6. So what do you notice about these two things in the middle? One's positive, one's negative. What happens to them? They cancel each other out. They go away. So now I have 16 minus, can I take the square root of 36? Yeah. So I'm just going to move over here. So I have 20 plus 5 over root 6. And 16 minus 6 is 10. Now, can I reduce that at all? Yeah, what can I take out? Take out a 5, right? You can take out a 5. So I'm going to have, if I take a 5 out of 20, I'm going to be left with 4. Take a 5 out of here, that'll just leave me with 1 root 6. And if I take a 5 out of 10, I will be over 2. So that's my final answer. Okay. Here we go. Do you guys want to do this one on your own, or do you want to do it together? Together? We'll do one more. I think we got another page of examples, so we'll do a couple on our own. We'll do a couple together. Ooh, I want to show you one for sure, because it's showing up on your test or your quiz. Okay, this one. Remember, we're only looking at the denominator. So what's the missing factor? So it's going to be root 3 minus root 2, right? Because this one has the add in it. And the top and the bottom of this fraction have to match. Okay. Root 3 times root 3. Root 9. Oh, kind of hard. I say it and then I don't write it down. Root 3 times by a negative 2. Negative 2 root 3. And then negative 2 times root 3. Negative 2 root 3. And then I have a negative 2 times by a negative 2. Positive 4. All right. So on the denominator, root 3 times root 3. Root 9 again. Root 3 times by a negative 2. Negative 2 root 3. Now I have a positive 2 times by a root 3. So plus root 2 times 3. And then positive 2 times by a negative 2. Negative 4. Okay, now we got to simplify a bunch of stuff. Can I cancel the ones on my numerator out? No, because it's a negative 2 and then another negative 2. It's like it's negative 2 outside and you go down 2 more degrees. I can simplify this one though. So that'll be 3 minus, so let's combine these. What are these? 4 root 3 plus 4. And then on the bottom, that's going to be a 3. What do I do with these two? They can't, because one's positive, one's negative, so they cancel each other out. Minus 4. This is still really messy. I'm going to add like terms together, so I can add those together. So 7 minus 4 root 3 over negative 1. Could I write this as negative 7 plus 4 root 3? Are those two things equivalent? Yes, they are. Which one's more correct? Trick question. They're both correct. You'd get full marks whether you leave it with a denominator or not. I think in some cases they'd like you to tighten it up to here, but it's okay if you leave it like that. Okay? All right. Okay, flipping over. I want to do this one together, B. I want to do this one together. What kind of root is this one? Cube root. So, if I have a cube root, what's the opposite to cubing something? Or cube rooting something? Cubing. Okay, see, I gave the answer away. I'm not very good at this game. And what did we say we were going to do? We were going to multiply the entire fraction by the denominator. So this would be the cube root of 9p. But that only works if we have a square root. What if we have a cube root? How many factors do we need? We need 3. So I can't do it once. What do I have to do? I have to do it one more time. How come? Because we need to cube it. What if it was a root of 10? We'd have to count them, 1, 2, 3. You count the original as 1. So we would have to multiply it by itself 9 times. If it was the 5th root, you'd have to multiply it by a 4th root. Just going to put a little star here, because that's going to show up on a test for sure, maybe your quiz. Okay? Do what you will with that information. Okay, so let's do this. When you guys are multiplying 3 numbers, how do you deal with it? How do you deal with multiplying 3, 4, 5 together? Okay, so do you multiply these two and then multiply by 5? Yeah. Okay, so if that's what you're going to do, that's great. You apply the same principles to this, okay? So if we multiply these two, we're going to get 12, and then we're going to take 12 and we're going to times it by 5. But I saw some people taking this and multiplying this by 3 here, and then multiplying the 3 by there, and then saying it'd be 12 by 15, which would be bad, oh bad. That's not how we multiply basic numbers, so that's not how we multiply complex numbers. So this would be an answer 60, hopefully. Okay, so let's multiply our first two together. So negative 7 times 2 cube root 9p. Over 4 cube root 81p squared. So these two combine to that, and then this one just gets written down there. So there's nothing we can simplify yet. So now we're going to multiply again. So we should get negative 28 cube root 81p squared over 4 times 2 is hopefully 8, and cube root 81 times 9? Anybody? 81 times 9? 729? Okay. 729, and p squared times p cubed. Okay, so if you've done your math correctly, you should be able to take the cube root of 729. I know what it is. because I trust my math. If you're not sure what it is, use your calculator. What's the cube root of 729? 9. Makes sense. Because what did you do? You multiplied 9 by 9 by 9. So numerator, negative 28 cube root 81 p squared over 8 times 9. And what's the cube root of p cubed? P. Okay, I'm just going to float over here for a second. So I have negative 28. Can we take the cube root of 81? Yeah? Square root for sure. What about cube root? No, sometimes they fall into both the lists, so just be wary of that. Like 64 is a cube root and it's also a square root, but 81 I don't think. That's why I have my perfect cubes and perfect square list at the back of the room, just so at a quick glance I can kind of see what they are. So I can't do 81, so that has to stay under the root sign. Can I take the cube root of p squared? No. So that still has to stay under the cube root sign. And then 8 times 9 hopefully is 72p. Can I reduce 28 and 72? I know I can definitely take 2 out of both of them, right? Because they end in an even number. No, 28 ruins it. Can I take 4? Okay, so I'm going to my calculator. 28 divided by 4 gives me 7. Good job, everybody. 72 divided by 4 gives me 18. And I know 7's a prime number, so I know I can't reduce any more than that. Does that make sense to everybody? So I'm going to reduce that fraction by 4, so I'm going to have negative 7 cube root 81p squared over 18p. Whew. That one was an ugly one, but it wasn't terrible. But the trick here is because we had a cube root, you have to multiply it not twice, but 3 times together. And it makes sense when you think about it, but if you haven't practiced it, it can be a little difficult. Okay. Shall we do another example? Actually, I'd like you guys to do an example. I'd like you to do C on your own. C on your own. I'm going to hit freeze and I'll do it, you do it, and hopefully I'll do it right this time, but I make no promises. So remember, you're multiplying by the conjugate. Don't even have it under the camera. It's poor video. Nobody's going to know what's going on. Let me know when you want me to show you. Can I show you? You've either given up or made it through. Hopefully, you've made it through. Good? Bad? Sorta? Do you know where you went wrong? Okay. Look, this is your first time seeing it, so if you did it wrong, no big deal. Just as long as you can identify where you're going wrong, that's the most important part. Okay. So the other two examples, I think you guys are capable of doing on your own, but I do want to show you the answers for the examples because I'd like you guys to do them. Okay, so D, just while we're here, D, that's the answer for D. So copy that down real quick. Okay, and then I'm going to show you the answer for A. A is a lot easier to copy. 2 root 17. Okay, so I'm going to stop the video. I want you guys to work on those two.